Hello, everyone. I'm just going to give a couple minutes for people to just float into the Zoom. I'm seeing attendees popping in right now, so I'll just give it 1 minute before we get started. Okay, well, we'll get started now. And the meeting here, the webinar is being recorded, so there will be opportunity to take a look at this after the fact as well. But I'll just say welcome to everyone who's joining us on today's webinar on net zero and the role of the mechanical contracting sector. My name is Ken Lascastle. I'm the Chief Operating Officer with MCA Canada. It was great to see the interest in this topic when we first launched registration. And we're very pleased to have today's webinar being brought to us by Mitsubishi Electric Heating and Cooling. So thank you to them as well. I think, as we all know, owners and building owners across the country are now looking to the built environment as one means to improve energy efficiency and ultimately lower greenhouse gas emissions and to achieve those net zero targets that we've heard so much about. There's a significant amount of work already being done across the country in jurisdictions across the country from the municipal level all the way up to the federal level. But ultimately, these improvements to the built environment are going to have an impact on mechanical contractors and MCA Canada members, particularly as we see new building codes being introduced and as owners are looking to retrofits of their built assets to improve that energy efficiency. Today, we're very fortunate to have with us Gary Chang, who is the lead engineer HVAC division with Mitsubishi Electric Heating and Cooling. As an experienced application engineer specializing in HVAC product application development and training, Gary has a passion for efficient and environmentally responsible HVAC solutions. So before I turn things over to Gary, we will have some time for questions at the end of the webinar. I would encourage you to use the Q&A or the chat functions on the bottom of the Zoom, and we'll keep an eye on those throughout the webinar and just keep track of some of the questions that are coming out. So without any further delay, I turn things over to Gary. Gary, the webinar is yours.
Oh, thank you, Ken. Like I said, my name is Gary. I am from Mitsubishi Electric. I'm the lead engineer over there at Mitsubishi Electric, heating and cooling in the HVAC division. So my mission in life is to promote Mitsubishi equipment and then helping people to achieve energy efficiency solution. So without further ado, let's get into this presentation on net zero emissions and the role of construction industry. So today we'll be discussing the challenges, the solution, and how we can achieve net zero emission, how it impact the construction industry to different building sectors in different applications and different stakeholders. And finally, we'll open it up for everybody to have a discussion session. Feel free to ask any question and concern, and yeah, we'll try to address it as much as we can. So global warming of the planet, for example, ozone destruction, right? So for a very long time, we all hear about the ozone depletion in the North Pole, right? So that's how it leads to the banning of R22 along with other kind of chemical being used. And waterway destruction, right? Habitat destruction, and then which led to cultivated land destruction, all due to climate change, right? So weather change and some of the, I guess, some of the life, some of the plants, they are only subjected to a certain living condition. And they don't have air conditioning or heating like us, or they don't have mechanical energy to do water. So with the climate change, livestock change, and then that will lead to food shortage. Then, you know, our likelihood will be threatened to our existence, especially of livability for a lot of different locations or different conditions. So, you know, the rising temperature, obviously that's the global warming, and that's a lot of times you will hear GWP, the global warming potential, and then which is lead to a greenhouse emission that is contributing to, I guess, trapping heat in in a green earth. And we are, as human, we are responsible for that, and then helping keep the planet nice and cool and green. So industrialization, we are going towards industrialization as we go into the 19th, 20th century, and the growth in population and the need for us to grow the economy and be more comfortable, and then to industrialize more land. It becomes our responsibility to help reduce the greenhouse gas emission. And then how we can help with that is through technological advancement. For example, heat pump technology, back then, 10, 20 years ago versus the technology that you see today has jumped quite dramatically, even compared to 10, 15 years ago. So climate change abroad, just while we all see the news, we all read, we all see videos from all over the place on the natural disasters, right? Flood, drought in all over the place, all over the world, and more wildfire, I guess, over there in south of border, in our neighbor, in the US. And climate change in local is, you can see, we're seeing more and more, I guess, extreme temperature or extreme condition compared to, many years ago, throughout different kind of a condition being created, being that where you're living in. So more and more natural disaster you may see, right? And then the weather have been shifting quite a lot. Even I remember even when I was a little kid and growing up, and then just seeing different temperature, and I can actually feel it. So outcome is the same, right? So whether it is happening abroad or living in our neighborhood, the destruction, the livestock, land, crop, properties, people, and then and only the planet, right? So one thing I want to bring up is, I would be honest with you, is not during I believe back in 2020 or 2021, and I would never imagine I will see it a day where Vancouver having a very, very bad air quality compared to even some of the Asian country, right? So wow, really. So that's really, I never really believe I will see it in my lifetime. However, that is due to wildfire, maybe south of the border or even in our neighborhood. So again, it's not just a regional kind of issue, but also a global issue for us to help reduce the global warming effect. So, and then more and more rain, right? More and more drought. So more and more on the extreme weather, that a lot of rain happening in a very short period of time, and the infrastructure may not be able to handle it, right? So that happening to a lot of flooding and then a lot of drought. More storm, more hurricane, and obviously will be destructive to a lot of people, and then to a lot of land, and to different kind of living condition. So what can be the solution to help reduce the greenhouse gas, or reducing the cost of this greenhouse gas? So we'll dive into how do we reduce it. So number one contributing factor in globally speaking is transportation, right? Industrial, buildings, agriculture, and others. So for us, for everybody in this panel or who's interested in this session, we're obviously looking into buildings. However, other places, right, like transportation, agriculture, industrial, those are very, very important things that some of the other industry bodies may be interested in and discussing. But today we'll be talking about buildings for as the main focus in here, because again, we are mechanical contractors, or you are mechanical contractors, and then serving buildings. And even for us, so in order to reduce the greenhouse emission, again, in buildings, we are contributing to about 17.5% globally. So if we can reduce it dramatically, even by half, right, that is going to be a contribution to the whole world, and then to help out. And then eventually the same practice may be able to be adopted by other industries, such as manufacturing plants, agriculture, right? So for example, build a better CO house for even for agriculture or for industrial, or reduce the number of transportation, or having a better means of transportation. So those are the exercise that can be transferred between a different industry, and then we are able to help and take advantage of that. So, and one of the reason is us, right? Careless carbon emission is we just back then or still now, or if you look at the image from 19th century London versus now, or you can see industrial, and then we gradually become cleaner and cleaner, or even you go to some of the developing country or some of the manufacturing site around the world, you will see they're not as environmental conscious. And then you can look into how we just simply dissipated or exhaust air into the atmosphere. Dirty exhaust air into the atmosphere, which is just in our part is not ideal. And as Canada, we're trying to move towards net zero emission or we're trying to gradually become net zero. Well, shouldn't say gradually, but we need to take part go into the net zero emission for the environment, for the world, and then for next generation or even our current generation. So we must achieve net zero based on Paris Agreement within all the country that the G7, we are cutting down the greenhouse gas emission to zero. And we wish to achieve 45%, or we want to achieve 45% emission by 2030 and eventually become net zero by 2050. So we can keep the temperature rise below 1.5 degrees C, right? So that is our goal. And I do believe we are on trend to do that, on target to do that. However, if we can help reducing the number of the energy that's being consumed or used by the building, that will greatly help us out by achieving this goal. So 7 countries is responsible for 50% of emission, and then in total of 20 countries is actually accommodate for 75% of emission. So which is very, very, that's what the 10-20 rule, where so that's where we really want to identify the biggest contributors, and then we can hope to reduce that as we go on. So construction industry and the building sector are interested in doing that. So at this moment, and then we're very happy to share this, is we're kind of on trend to reduce the greenhouse gas emission. However, just not fast enough compared to 15 years later. We are only decreasing by 9%, so we can do better, hopefully, and then we can achieve the goal in 2030, which is reduce it in 2030. We reduce it by 45%, and eventually will be 100% net zero by 2050. So we can definitely do our part and become better and better to keep the temperature down to 1.5 degrees C, the temperature rise. However, the main sector will be oil and gas, is 27%, and transportation, that's for Canada between 1990 and 2020. So you can see this is a chart. We're taking it from another resource online. So, and then you can see oil and gas, transportation, and buildings. We are the 3rd biggest contributors for the growth for the GHG gas. With oil and gas, with transportation, we are moving towards a better green tomorrow. I think everybody is using. I see more and more electric vehicle on the road, not just in places like city of Vancouver. The other day I was in Saskatchewan, and I start to see even on the colder climate, people are adapting electric vehicle and more. And obviously the stakeholder, the decision maker, or the people who is helping the owner to make the decision, we need to contribute, and then to help convey the idea of reducing the greenhouse gas. So what are the stakeholders? Obviously all of us, the provinces, municipals, developers, builders, everybody, the designers, right? Whoever is living in this building or close to a building, because we are all sharing, I guess what I like to say is we're all sharing the air. So therefore, we try to get everybody involved, and everybody needs to be on the same mindset or similar mindset and moving towards a greener tomorrow or reduce the carbon emission. Now you may, not just on the owner, just not just because the government told us to do it, right? But also having this mindset and then just trying to share that mindset with everybody and then just trying to move it into reducing greenhouse gas. And lastly, the industry advocacy groups, right, such as MCAC invited us to do a presentation on net zero emission. So which is also sharing our thoughts, our ideas, and then some we see on our daily life to see and share our information with everybody. So climate action plan is a big thing for us to see and then to follow for city, municipalities, for the authority having jurisdiction to incentivize developer and user to adopt green energy. So, and then by doing so, they are also continuously updating standards and target in order to reduce greenhouse gas emission. And a big contribution is electrification on buildings to help reduce the greenhouse gas emission. And then developing a net zero community for a certain community that's actually going on net zero, and then that can become a model for everyone else to follow and adapt. And then also to learn about what's available in the technology or in the trades, right? Not just in Canada, but also globally, in seeing what other countries are doing, what we are doing, and then what we are doing and what other countries can take part from us to learn about technology, to learn about the practice that we are using and share it, because after all, we are a global citizen that we can share with everybody to achieve this goal. And some of the challenge, obviously, for the stakeholders are budget, quality, time, and profitability, right? So that's always the big thing is, right, the golden triangle of the product management is time, quality, and budget, right? So, and then that will also lead to profitability. We can have a very, very nice and fancy solution that can build everything, right? Now, we always say, if you give unlimited budget, unlimited time, then you will have the best quality, obviously. However, that's not always the case. So marketability of the buildings, leasability, can we having the end user or share the cost with the investor, with the developer, or even with the end user, right? To see if it's attractive a solution for everybody, not just on the efficiency side of things, but also on the comfort, but also on sellability, right? And then availability of the technology, and then to see, well, I see this amazing thing from overseas. Let's say I see this amazing technology from Japan. Is it available in Canada, right? Or, okay, so it's available in Canada, but do we actually have the tradespeople to help installation and then service the equipment, right? So those are different challenges that, especially nowadays with the help of internet and then with the global citizen traveling around the world, we all see technology around the world that we look at, we can be adapted to our market. However, sometimes our jurisdiction or other people's jurisdiction may not be able to adapt it right away. So therefore, we're just kind of also relying on a different kind of stakeholder to help us making the decision on bringing different technology to different stakeholders. And one other resource for us is obviously for developer, it will be incentive, right, to return in development charges. So you build so one thing on top of my head is if you achieve a certain green standard, I can't recall which jurisdiction, but maybe in here or maybe in States, but let's say, I do know there, if you achieve a certain level of your energy efficiency or the certain standards, you can build 2 additional or 3 additional stories in this municipal or in this jurisdiction. And that is hoping to, with the additional income from the additional floors, you are able to recoup the cost, right? And then same thing for Toronto Green Standard that we have in the GT in Toronto, and then City of Vancouver and other jurisdictions are starting to adapt different kind of strategy or different kind of guideline or even building code to help with to guide the developer, the manufacturer, the contractor to achieve those goals. And then lastly, the climate change fund program is obviously to help by adapting different technology, different method, by lowering the carbon footprint of the building, and then we are able to, maybe getting additional funding and then incentivize developer, owners, contractors to help participate in the program. And other advocacy group, in the world, I mean, in Canada locally, are also good resources for people to share, to go into and learn more about it. For example, zero carbon on things like zero carbon standards, passive house standards. There are different group of people, and then also LEED building standards. There are different group of people, that different industry event that's discussed then specifically to help with lowering the greenhouse gas. And one of the big topic right now is obviously switching from fossil fuel to heat pump technology, right? So heat pump using electricity, whereas a natural gas boiler is burning natural gas. So the CO2 emission is maybe different. Well, not maybe, but they will be different between the 2 technology. And then switching from fossil fuel to electrification is obviously a big topic. So some of the challenge, obviously, switching from fossil fuel to electric heat pump is resistant to change, right? So a lot of time people just say, hey, they don't want to be the first one to do it. We are facing this kind of a problem as well, or the issue or concern. However, many years, heat pump technology has been developed globally and also locally in Canada for many years. So you won't be the first one to do something in a lot of cases. However, a lot of resistance to change because it's a new technology for a lot of people. And regional stakeholders, for example, in certain region, even within Canada, fossil fuel is cheap, gas is cheap, right? Natural gas is cheap, oil is cheap, so fossil fuel is cheap. So that, and then also we have a dirty grid. So for example, the electricity may fluctuate or may use or delivery may not be as simple as from one location to another, right? So for example, electricity in Toronto, City of Toronto versus electricity in Banff, right? So those are the grid maybe slightly different. However, those are also contributing to the decision makers on their regional kind of decision needs to make. And lastly, the harsh climate. So again, many people having a challenge, and then especially us in Canada, we the north. So we're going to a harsh environment, right? Harsh temperature, it goes to -35 all the way to -10 as the design temperature. So those are different things. And then there's a lot of snow in many different regions. And lastly, the technology availability for our region, and then for different as well. That's contributing to whether it is adaptive to a lot of people. Some of the challenges for stakeholders, for architect and design engineers, obviously liability, right? So that's the thing is, a lot of time people don't want to be the first to adopt the new technology because they want to have a reference point as well. So liability on the architect and design engineers to probably design a system. And cost and estimation, usually that is required because it's so new. How do I estimate it? How do I budget the project? So based on new technology, right? And then the minimum standard based on requirement. What is the code compliance? And then lastly, the lowest bid, because premium solution that's gonna last, that's gonna be comfortable versus economic solution. A lot of time it is a challenge for a lot of people. Sometimes you learn the most wonderful thing in the world. However, the cost may be a premium compared to something that's just achieving the minimum standard. Then it's just kind of a challenge for a lot of time for a lot of people to go into, and then to overcome on new technologies. And for builders and contractors, obviously comfort of zones, and then they're usually or chain of command. For contractors, builders, they are depending on where you are in the process. Some can be raise their voice and then discuss it in the early stage, but a lot of time, you're just there to contribute to make a project success. So sometimes you may not be involved with decision making, so which is not able to just raise your concern. So, and then a lot of developer may only care. Again, some developer may only care for the lowest bid, and that's meeting the minimum requirement. So that's really the challenge, right? In my previous life, I do hear they don't want to know anything fancy. They just I just want to build this quick and cheap. That's it, and move out, right? So a lot of time is lowest bid, and then so a lot of time builders, contractors will not be able to raise their question and concern. So those are the challenge for different stakeholders, and what can be done to help raise your question and concern or overcome the challenges, such as trainings, workshop, right? And then capacity buildings, and then proof to build. So different resource, you can say, well, I installed this many different technology to different locations to show your knowledge experience by attending different trainings, different workshops, and then to build a building that is high efficiency and then and high quality. So those are the good resource for different stakeholders to join us to do it. So there are different project delivery steps that we need to take into consideration, and then every step of the way, in our opinion, is to really keep in mind that what's the goal we're trying to achieve, and then while having the net zero and the role of mechanical contractors in mind to help deliver a successful project. So from planning, designing, construction, execution, and completion, each step is important, and we will be able to impact the project in different ways during the construction, right, throughout the whole life of the building. So for example, you may switching one technology to another, just switching on right high efficiency to switch from condensing boiler to atmosphere boiler, right? That will be impacting obviously a lot of GHG emission throughout the life of the building, because not everybody will change boilers every 5 years, right? So those are just one example. Or changing the piping, changing the refrigerant type, right? So planning in the beginning, and then also you say, well, it just won't fit inside the space. So design and construction and then execution are leading to completion. Really to still keep your target in mind, and then still keep the net zero kind of target in mind. So there are different methods to help to deliver a project: construction management, design bid build, which is traditional plan and spec, design build. I think we'll see more and more, and multiple prime design assistance integrated with project delivery, or public-private partnership, right? So you as a stakeholder, as the owner, as the consultants, as a designer, as a contractor, you have the ability to support, to assist, and then looking for helps, right? And then raise your question to see what will be the most beneficial method to achieve for a project being successful to achieve net zero kind of target. So a different approach, right? Design build approach, and then design assistant approach, or design spec kind of method that we see. Design bids build, the conventional approach that we usually or I used to see will be design bid and build, where owner will hire a designer, contractor, architect, right? Sub-designer, subcontractors to achieve a building where people are getting involved. So for example, owners, mechanical contractor, general contractor, and architects. Or they may be taking a design assistant kind of approach. Again, the owner is owning, or the architect and the contractor are reporting to the owner. Or we have a design build approach where the owner is working with the designer or criteria developer, right? So you design and then you build, which all of you can see the contractor play an important role in here. So always having this in mind, and then bring your ideas to different to achieve the goal. And then choosing a delivery method that is appropriate for your design or for your target lead. Is it time cost, right? Different choices, and then impact on different choices. Obviously, the time, the budget, and the quality. Those are the triple constraint for any project management success, right? To look into the best value, or just do on lowest bid, which is the lowest bid may not always be the most appropriate or the best solution. So looking for a good value, good delivery method is important. So different, also different contracting format, cost plus fee, guarantee maximum price, or lump sum, or target price. So really to look into different delivery method and be responsible and be responsible, and then doing to deliver a quality design process. And then obviously you need to also assess risk assessment to assess risk, and then allocate the risk to different parties. Is it responsible for the contractor? Is it responsible for architect, or everybody having a shared responsibility? So all those things are important to consider when you are taking different design kind of approach. And then we obviously want to keep it in mind, and then raise your concern, and then to eliminate the risk, and then hoping to achieve a goal for the stakeholders. So for owners, obviously, owner needs to control the design detail, the project outcome, and all the prime contractors, right? You are the owner, you hire the people. That needs to be based on the budget and based on your quality of work, right? So the design detail, don't leave it too vague to the people. Don't just say, I want heating and cooling, right? And then really dive into giving more detail. And then controlling the project outcome. Be specific, right? Keep it simple, stupid. That's KISS rule, to control the project outcome, and to control all the prime contractors to achieve a target, to achieve the goal. And then changing orders, adapt the budget as quickly as possible, and then finding the best solution, best value for the budget. And lastly, the project schedule, right? Time is money, so fast track project, and then to map out the total project duration in order to avoid delays and disputes in the project, or any cause of any delay. So very important to early stage to establish the timeline, and then try to follow the timeline as possible based on the project management needs on different goals, objective, and then detail the stakeholder analysis, the risk assessment, and then scheduling, right? Identify any the critical path for a project to be delivered on time, on budget, and with high quality, and then which is also will be significantly helping the owner to achieve a successful project. For manufacturers such as us, right, and our role is to really introduce what other technology is available to the owners to people, to contractor, to engineers, to designers, to architect, that everybody know. Sometimes and especially people, just because things have been done in the same way doesn't really mean that it's also been should be done in the future, right? So for example, if that's the case, then heat pump technology may be a challenge for a lot of people. However, we can see more and more on different technology being applied to help achieve net zero. So in our role as a manufacturers is we're introducing technology that's good for the people and good for the planet, and continuously improve on our technology, right? Through training and workshop, we can learn from what people are looking for and what people are having challenges for. And then we can take those experience, taking those notes, and then back to the manufacturers, engineers, and then share our thought that's suitable for our industry, for our market. And obviously readiness and availability, right? So, well, you introduce this amazing technology, but you're telling me that it's available in 10 years, then that's sometimes not ideal. So readiness and availability through training and workshop, and then through continuous improvement, that we are able to introduce people and planet friendly technology to the general public, to the owners. And obviously we need to also meeting the regional demand, because in the end of the day, we want to introduce, or manufacturer wants to introduce something that's suitable for people, that people will purchase, right? So that is the role of manufacturer, to help playing in this net zero and to help achieving energy efficiency solution. But for our challenges in Canada, is obviously Canada is a big country. So from coast to coast, there is a very, very diverse climate. So a project, a building that's built in British Columbia versus a building built in Ontario, in Calgary, or Quebec City may be a lot different compared to in terms of method, and also as well as the energy standards. So we can see over here, this is what a nice map to show the different different design consideration. Just on the mechanical side of things, heating and cooling. On the heating side of things, you can see Edmonton is -32 and Victoria is -5 or -4C, whereas Ottawa is -25. Even within Ontario itself, Toronto is -18, Ottawa is -24.2, right? So 6 degrees C of difference. And then even for Vancouver, not in Vancouver, but in British Columbia, Victoria is -4 degrees C, whereas Kelowna is -18C. And then Atlantic Canada, next to the ocean. So again, the design temperature is quite different. And obviously different zones, different location have different weather pattern, right? The snow buildup on the roof, right, may be different region by region to see. So our challenge is to bring technology that's suitable for at least majority of Canada, and then because of the diverse of our weather. So Canadian challenge is obviously to provide hot water and hot air for the building, because you can see over here, people will require heating during winter time, and then we can just introduce one thing that's suitable for everybody. If we just introducing one product, it may be too much capacity for people in Victoria, or too little capacity for people in Edmonton, right? So those are the challenge that we are facing as a manufacturer. And then also hot water usage. Everybody is using hot water on a daily basis. Showers, cooking, washing dishes, right? Even running dishwashers. So those are the challenge that is immediately we can help to reduce the greenhouse gas based on the on the solution that we are proposing to the industry, as in the heat pump solution. So for example, air to air. So the air-to-air heat pump is obviously taking the heat or transfer of heat from the outside ambient condition and then apply that to the indoor condition, right? So reject the heat out to the outside of the building by removing the heat through to the outside by the means of refrigerant. And then so using outside air plus mechanical energy to produce a comfort air. And then we also have air, oops, sorry about the typo, air to water. So it is again using the outside ambient air plus mechanical energy to heat or cool the water to provide a comfortable solution for the indoor environment. And lastly, we have water to water. So for example, we're using water such as geothermal or chiller boiler to transfer heat that is being that needs to be rejected or absorbed from the indoor space, right? So for example, in cooling time, in cooling dominated location, we are using water. We are providing cold water to the indoor space to absorb the heat. And then those heat will need to be transferred out to another side on the, I guess what we call a condenser side, to reject those heat into the water stream, for example, geothermal or a cooling tower to reject the heat from to another location. And one couple of reasons we are seeing more and more of heat pump solution throughout Canada is because of its efficiency, not just in cooling, but also in heating due to its high COP, because we are getting quote unquote free energy from the atmosphere, either through the air source, which is outside air, or through geothermal, which is the ground temperature. That will help reduce the greenhouse gas because we are producing, we are requiring less energy to achieve a similar amount of heating and cooling compared to a more of a conventional system like fixed speed compressor or a natural gas boiler, which will ultimately reduce the greenhouse gas. And smaller carbon footprint, right? So smaller, they use less energy, so compared to, or they produce less greenhouse gas. So that will be able to having a smaller carbon footprint in terms on the production side of things, like production on heating and cooling, to help achieve a comfortable solution for our environment in Canada. Again, to hopefully to help address different needs for different environment. So one of the technology that's suitable for our climate is cold climate heat pump. So for example, the hybrid heating technology that's available right now in the market that's helping addressing a different temperature requirement for a lot of our climate. So for example, Ottawa, Toronto, London, Sudbury, Kelowna, Atlantic Canada, Montreal, Quebec, where we are able to, we're able to introduce what we call a hyperheating technology to produce heat even at low temperature. So how does it work is, so imagine it's in heating mode, it's shooting out hot refrigerant. So hot refrigerant become cold refrigerant through the indoor unit because it's releasing all the heat. So some part of that refrigerant, that cold refrigerant, before it go back to the condenser, is actually going into the compressor to cool your compressor down so it can run on a higher frequency to generate more heating capacity or changing the, doing more work to the refrigerant, if you may. So in order to do that, if there are technology right now in the field or in Canada that's capable of producing 70% of heat, even down to minus 30 degrees C. So high heating performance, which is in a way is you in certain conditions or in certain territories or certain regions, requirement for backup heating is no longer required since some of the technology can do heating down to minus 30 degrees C, guaranteed performance, and also provide adequate amount of heat for up to maybe 70%, even at low temperature. So in some of the jurisdiction, in some of the area in Canada, they are already adapting net zero. Not just on one building, not just on a few buildings they are trying, they are actually developing the entire community as a net zero technology. So for this building, there are over 70 acres of land that's using solar panels and as well as rainwater harvesting to help reduce the carbon footprint and then reduce the energy consumption for the equipment. Energy consumption from your, or actually, if it's net zero, there's no consumption, but to reduce the consumption from the government or from the grid. And then by helping that, they are able to use heat pump technology, which doesn't require fossil fuel, which also greatly reduce the greenhouse gas production for this this community. So not just on a building to building basis, but we are thinking about as a whole, as a community, as a group, that how we can achieve net zero, right? Not just on heating and cooling, but how we can take opportunities from different types of technology, right? Can we harvest the rainwater, right? Can we take those rainwater and then can we utilize them to help achieving or lowering the heating and cooling or other kind of usage. Again, so you guys can go on Google and check it out. So those are the photos that you can see, mixed use community with a lot of solar panels on the roof, and then utilizing heat pump technology to really help drive the energy down. And then if you require less energy to operate a building, then obviously a lot of time the solar or renewable energy will be able or suitable to help you achieve net zero. And besides that, there's also a case, the Canada First Net Zero Design Certified. So this one is in Waterloo. So this is the first office building that's utilizing a net zero design. So open loop geothermal, solar panel, variable flow VRF condenser as the water source condenser, right? So using geothermal, so you are using the ground heat, or during summertime, you are rejecting all the heat from the building. And then in wintertime, you are absorbing the heat that you are rejecting during summertime to help maintain the comfort in the building space. And lots of solar panel in the back, in the parking lot, as well as high efficiency kind of windows or on that. So it's not just on the heating and cooling side of things, but building envelope also playing a big role on providing the heating and cooling. And so this is the first technology that we see, the hybrid heating technology, to help address the different needs for Canada based on different temperature requirement. However, second big usage is hot water consumption. So Canadians use about 75 liters of hot water at home each day, which is about close to 20% of energy use. And this is taken from NRCan based on their 2017 usage. Therefore, there are also other technology that's currently available to help producing hot water using CO2. Using CO2 and a heat pump technology. So you can see over here. So this is a simple application. You can see we are having storage tank. We have hot water. That's hot water for shower or for faucet to use. And you will notice there's an air to water heat pump system on the outside, which is absorbing heat from outside air to produce, and then through the help of compressor and then also the refrigerant to produce high energy, to help heat out water from, let's say, 10 degrees C from the city all the way to 65, 70, or 80 degrees C, depending on requirement inside the storage, to help achieve lower your natural gas consumption as well. and then to produce hot water. So the heat pump technology is already available. That's utilizing the temperature, I mean the air. And also another thing so a lot of time people will say, well, heat pump technology versus cold temperature, but hot water is also required during summertime. And I will even argue that people taking more shower in summertime, right? So hot water heat pump, some of the technology that is being introduced to the world by us is high efficiency, right? So obviously any sort of heat pump technology, they are absorbing heat from outside air and then with the help of mechanical systems such as compressor to achieve high COP. And we're utilizing CO2 as a refrigerant to reduce, which has a global warming potential of 1 compared to other type of refrigerant. And it can operate down to minus 25 degrees C, and then obviously very, very high quality. So those are the technology that's currently available from us as well as from other manufacturers to help to combat for or to help with the cold climate. So I think I have 5 minutes left. So this is the end of our presentation. Any questions? Thank you for listening, and we'll open up the floor to any question.
Thanks, Gary. I haven't seen any questions come in. I do have one though, and thank you very much for that presentation and the information you provided. One of the areas that we know there's going to be a significant amount of work is with respect to retrofits. We know,
Yes.
The built assets across the country, we can't, we certainly can't tear them down and rebuild. And there's going to have to be a lot of work done because many of them have reached the end of their service life. What challenges do you as a manufacturer see in that realm, in that sphere, with respect to improving the energy efficiency of the systems, and whether or not, how much extra effort is going to have to be taken to retrofit those buildings, particularly, deep retrofits, not just, retrofitting the systems themselves, but for owners who are looking to do deep retrofits?
Yes. Okay. Yeah. Thank you. Thanks for the question. So some of the challenges, obviously, will be the building built, let's say 30 years ago, 20 years ago, even the building that's built 5 years ago, as building ages, everything is start to wear and tear, right? And then start to sink. So similar to government incentive, right? They say, oh, apply more insulation, apply more seal. So I would say the challenge is, for us, is people don't look at that as a whole building solution, right? They are looking, say, well, I need more heat, buy more heat, right? I need more cooling, get a bigger system. However, I will always encourage people to always look at as a whole building solution, right? So for example, get a better window, seal a window, and then that will also dramatically reduce your energy consumption, right? Or sometimes people just say, hey, even for our Mitsubishi office, we recently going through a retrofitting system. And then just by introducing what we call an energy recovery solution, right? And then that will dramatically reduce the system. So it's not just heating and cooling, but also other means, right? Ventilation, right? Air is air, air for heating, air for cooling, but how we can help achieve energy efficient for those solutions. So I guess the challenge is, as a manufacturer, sometimes if we raise this up, it's like, well, you sell us heat pump, right? Why are you talking about windows, right? Why are you talking about seals? So those are the challenges. However, I encourage everybody to not just looking at mechanical equipment just because mechanical equipment manufacturer or mechanical contractor, just looking at a whole building and then apply some of the common sense, if you may.
We do have a question here from Eric, and I'll read it out to you. As electrification is the answer, do we have the generation capacity and distribution infrastructure to meet the targets, keeping in mind that we're looking at renewables, hydroelectric, wind, solar, or nuclear generation, some of which are long-term projects taking many years to complete?
Yep, I'm
So-
reading it. We have a that's something that's a little bit of outside our control to say, right? Like we all know, some of the power plant, the nuclear power plant in I guess in Pickering, right, is due for retrofit or decommission or whatever. But again, that's something that's not getting to there. But that's also another thing that the government will need to do to really think about producing those things. However, as the consumer, as the manufacturer, or as the, how can we say, consumer for electricity, we are doing our best part to help reduce the consumption, right? That's the first thing is, and then we're also pushing the legislation to look at into not just retrofitting on the buildings, but also updating your infrastructure as well. So I think the goal number one is to help saving the electricity first.
And to Eric's question as well, we saw yesterday in yesterday's federal budget, there was some significant funding announced with respect to the electric infrastructure across the country and some of the projects that are going to be forthcoming. I think in part due to some of the feedback that ourselves and other associations have provided regarding the infrastructure's capabilities to take on these retrofits and some of the new equipment. So certainly there is an awareness that there needs to be better grid infrastructure across the country to accommodate this electrification that we're seeing. So, but I think we'll have to sort of see how that rolls out from the federal budget and on that advocacy side of things as well that you allude to, Gary. I have another question regarding how these technologies are going to be specified in the future from your perspective, and whether you see it sort of being a more performance-based specifications, or if we're still going to see some prescriptive specifications on the actual technology that needs to be used, because it does shift the risk a little bit and the onus to the contractor level in some of those situations. So do you foresee challenges there or a shift happening there?
No, I don't really see it as a challenge. It's just a different way to adapt things to do. And then depending on the relationship or depending on the approach the owner designed it to use, right? So prescriptive kind of approach, right? Or versus performance-based, in the end of the day, it's the preference on, the owner plus the design professionals.
Gary, I'm not seeing any other questions at this time. What I would do, though, is I would encourage any of our attendees, if they do have other questions, feel free to forward them on to MCA Canada. We'd be happy to circulate those back to Gary and see if we can get some answers for you as well. Yep. Gary, on behalf of Mechanical Contractors Association of Canada, I just want to say thank you for the presentation, for your time. Thank you to Mitsubishi Electric Heating and Cooling. I know this is a topic that's going to be one we're going to be talking about for a number of years, especially as we start to see changes in the code cycle and code development relating to net zero. So appreciate your insights here today, and to everybody in attendance, thank you for joining us.
Yes, and lastly is 2030 is right at the corner. It's like so we wake up one day and then it's 2023.
We're
right?
The code cycles, some of the targets that have been set are coming at us quickly. So we appreciate the insight and the ability to dialogue on some of this stuff, because it's going to be a learning curve for many of us. So again, Gary, thank you for taking the time. And for those of you in attendance, thank you for joining us. Take care.
Thank you.